All right, guys, so we're going to talk about functions, and the first thing I'm going to do is define what a relation is. So you can see over here, we have a relation between two sets is a collection of ordered pairs containing one object from each set. So here we have set A, which we can call our x values, and then here we have set B, which would be our y values. We're used to that from the ordered pair here, x comma y. So you notice that in set A, I have 1, 2, 3, and 5, and then set B is 3, 4, 7, 8, and 9. So this first ordered pair that I created, 1 and 3, I have the 1 that comes from set A, and the 3 comes from set B. And then here I have 2, 4, so 2 is right here in set A, and then 4 is in set B. Now I repeated the set A value again, so 2, 7, so it's 2 and then the 7 value, which is fine. It's just a collection of the ordered pairs, one from each set. So you can see how I created the rest of these ordered pairs. Now let's talk about a specific relation, which is a function. So a function is a type of relation that assigns to each element x in the set A, which is our domain, remember we talked about that, exactly one element y in set B. So set B is the y value, which is the range. So your x values are your domain, the range, the y values is your range. So if you look, again, I have the 1 and the 3, which I have right here set up. Then I have 2 and 4, and then I did 3 and 8, and then 5 and 9. So this is a function because each element x has exactly one element y. Basically, the x values cannot repeat. So that's just a good notation to put in there, is that x values do not repeat. That's one little trick that we usually tell our students to remember. So let's look at these examples. So which of the relations is a function? So going by what I just told you, let's look to see if any x values repeat. So I have a 2, and then I have a 3, then I have a 5, so I'm good so far. But then if you look here, change the color, I have 7, and then 7 repeats. So 7 is mapping to 11, but then it's also mapping to 14, and that can't happen. So this is not a function. It's a relation, but it's not a function. Looking at B, now you don't have any values that I'm listing out for you, and I couldn't possibly list these all out because this is a quadratic function, which makes a parabola, so there's an infinite number of points on here. They're all over the place here. So what do we need to do? Well, if you recall, we can look at something called the vertical line test. So what that tells us is if I can draw a vertical line through any point in the graph and it only touches one time, then it is a function. So I'm going to go ahead and switch this up, change the color and change the fine tuning on it. So if you look, I can draw a vertical line here and notice that I only touched the graph in this one spot. If I do another vertical line here, notice that I only touch right here, one spot. So you can see that no matter where I do this graph, no matter where I put the vertical line, I'm only going to touch in one spot. So this is a function. And now we're going to scroll to C. I can do that this next part later on in the video. So here we have 1 is going to 2, it's fine. So we have 3 is going to 2. Now some students say, oh, well, the y value is repeating, so it's not a function. No, that's okay. The y values can repeat. It's the x values that cannot repeat. So I have 1, 3, 5, 7, and 9, and none of those are repeating, even though some of them are mapping to the same y value. That is okay. So this is a function. All right, so I'm going to stop the video here. I know the whole thing's part of section 1.1. Next thing I'm going to do is talk about evaluating a function, but I'm going to do that in the next video.